Hello viewers, this is Mitsu with my bonus project for CSC 355. Here I've made a cellular automaton, specifically Conway's Game of Life in Minecraft. The Game of Life is a very simple example of cellular automaton, where on a grid of cells, each cell must follow 4 rules before determining the state of the same cell in the next generation. There are only 2 states, alive or dead. You can see that in each generation, each cell behaves randomly. Although random, the same behavior can be replicated over and over again with no deviation. There are a few interesting configurations that people have discovered, which includes spaceships, or popularly known as gliders, explosions, and also tumblers. I've set up 6 different presets of interesting cell configurations. Let's take a look at my favorite, the tumbler dance party. Notice each preceding generation, all the tumblers are behaving the same way. The programming logic is fairly simple. Here I have a stack of command blocks which are fired sequentially. Each cell in the 55 by 55 grid has one of these bad boys underneath. The upper command blocks utilize scoreboards, or essentially memory, and count how many sea lanterns surround the subject block. Once the counting is done, the lower command blocks compare the total number of sea lanterns surrounding the subject block to constant values also stored as scoreboard values. Depending on what condition is met, aka the 4 rules, the block for the next generation is stored there. When every cell is checked and next generation is generated, we clone or copy the entire grid at this level to the very top and begin the process all over again for the next generation. Essentially, the resulting cell for the next generation are final states. The 4 rules are the grammar of the language, and the alphabet is just on and off, or 1 and 0. My implementation is basically a Turing machine, since I utilize memory and reading and writing data. I've learned a bit about the importance of time complexity when I ran into lag issues. I initially attempted this project by using invisible armor stands that iterated over each cell quickly, row by row. It's basically what I'm doing here. However, when building contraptions in Minecraft, you have to be aware of all the things that the game does in the background every tick. A tick is a measurement of time in which Minecraft operates. Since an armor stand is an entity, Minecraft has to keep track of the position of the entity every time it moved, which raises the number of processes happening in the background. In order to fix the problem, I realized I could separate cell checking into rows of chunks. A chunk is a 16 by 16 by 256 section of the map. Every time a block has changed within the chunk has to reload. With what I was doing before, I was iterating row by row, going back into chunks that had been updated several times before, which was not efficient. I realized in some cases, something as small as a single computation can be fatal to the program's performance. I hope you enjoyed this video.